In this video, we're going to cover learning objective B and talk about algebraically how do you find the zeros or x-intercepts and the y-intercept of a polynomial. Now, you can find the zeros of a linear polynomial, a quadratic polynomial, or a cubic polynomial, or even higher. But let's try to figure out what does it mean to be a zero. A zero for this particular cubic polynomial, here's one of the zeros right here at -2. And if you keep track of that -2 and go over to the table, this is how you can actually tell in the table that it's a zero of the function. So one thing we know is the zero is also the x-intercept. And when you look at the ordered pair that gets created by that, the other thing we can see what happens is y equals 0. So to find an x-intercept or a zero of a function, what you mathematically need to do is set y equal to 0 and solve. Now let's also talk about the y-intercept. The y-intercept is just where the graph crosses the y-axis. So on this graph here, we see that as the y-intercept. Now the ordered pair for that is going to happen right here at 0, -2. So to find the y-intercept, we can see the connection here. Notice x is equal to 0. So to mathematically find y-intercepts, all you do is set x equal to 0 and solve. So let's start with this particular polynomial function. They want us to state the degree and then find the y-intercept of the graph. Now the first thing to find the degree, it means the highest exponent. So when you look at this, you actually see two separate exponents. So you have to realize, what do you actually do between this 2 and the 3? Well, let me rewrite it. What if we didn't have the -1 and the +4 there? If that wasn't there, and we just had p of x equals x cubed times y squared, what would you do? Do you add or do you multiply those exponents? Remember, this just means do x 3 times, this means do x 2 times. So in this case, what you would do is you'd add the exponents, and this would be x to the 5th, which means it'd be a 5th degree polynomial. Well, this particular equation works the same way. Now, if you did the math longhand to put this in standard format, it would be incredibly tedious. What you'd have to do is write this out as x minus 1 3 times, and then you'd have to do x plus 4 twice. Now, if they said put it in standard format, what you'd have to come in, you'd have to FOIL these two and bring it together. Then you'd have to come in and do a second round of multiplication and another round of multiplication and then another round of multiplication. It would take a long time. All you need to recognize here is that this equation is very similar and works the same way. So I'm not going to do any math on it. I'm just going to realize here I would add the exponents. Therefore, the degree of this polynomial is a 5th degree polynomial. Now, we are going to graph it. So remember, in your graphing calculator, just click the y equals button, and you can just type this exactly as you see it. And then after you do that, hit the graph button. Now, if you're in the standard window, which is at zoom number 6 is standard, your window is going to be 10 to -10, and you're not going to get all this great detail. What you'll get is this one right up here. So I actually had to go in to my window and adjust it. So we do see some nice detail. Now to find the y-intercept, I can actually see it in the graph. It's right there, where it looks like it's about right here. Well, to mathematically find the y-intercept, remember, x is just equal to 0. So all I'm going to do is this. Instead of writing p of x, I'm going to say y, and I'm going to say equals 0 minus 1 cubed times 0 plus 4 squared. If we simplify that, this is -1 cubed, which will be -1 times -1 times -1, which will be -1. And then this value here would be 4 squared, which is 16. So therefore, we can tell that the y-intercept on here is going to be equal to 16. Now, if I went to the actual table here, which is under second graph or second table, if you scroll down, what you would be doing is looking for where x is 0. Well, notice where x is 0 is right here, and we can see that the answer is -16. Now be careful on a test or a quiz, you must be able to show me the algebra to support the answer if you see it in a calculator. Okay, let's continue on with the same polynomial. This time find the x-intercepts. Now as I look at the graphing calculator, it might give me some help. It looks like this might be an x-intercept here. I can't quite tell. And it looks like that might be an x-intercept here too. So it looks like there might be two. But you know what? The math will tell me where they are. All the math says to do on here is to set y equal to 0 and solve. Well, p of x is my y, so let's just do that. So this is what we have. And to solve this, don't overcomplicate it. This is called factored format. So this is one factor of x minus 1 and another factor of x plus 4. We're going to be looking at this quite a bit in Chapter 7. Now there's two different ways I can approach to solving this. My first option is just to take this factor and set it equal to 0 and this factor and set it equal to 0. So x minus 1 all cubed equals 0, and then x plus 4 all squared equal to 0. Let's look at this one here first. We need to get x by itself, and we have to move the 4, but first we have to move the 2. How do you get rid of a squared? Well, you can come on in and take a square root. And when you do that, you get x plus 4 equals 0. Finish this off, and you're going to see that one of the zeros, or the x-intercept, is at negative 4, which is exactly what it looked like in the picture. Now this one here, to get rid of a cubed, you can take a cubed root, or you can also raise it to the 1/3 power. So if you remember that, 1/3 power means cubed root. So then you're going to have x minus 1 equals 0 to the 1/3 power, or the cube root of 0 is just the number 0. And solve this by adding 1. So another x-intercept, or 0, is at 1. So those are the two answers. Now another way you could have approached this problem is if you wanted to, you can just show all these factors written out longhand. So I would say 0 equals, and I would do the x minus 1. Again, that's happening 3 times. And then we have the x plus 4 twice. And then what you would do is you would just take each of these 5 factors, because there's 5 of them here, you would set each of these individually equal to 0 and solve. Well, these 2 are going to equal negative 4, and these 3 will all equal the number 1. So you'll get the same answer. It's just a slightly different approach where you don't have to deal with the cubed and the squared.